question 10, you know. The last question on the paper. Vectors and matrices. Alright, this is what I'm going to. So you have matrices here, so. If we find the inverse of one matrix, that a part A and B in a C, one diagram with some vectors. In a D, you have a diagram on a graph and a vector this too. Alright, so if we start out this thing and now let's see what I got. It say calculate the matrix product. And you have them two things that then call the matrix product. I'm going to see copy the question and put it over here so. Alright. Right, that's how I put it. And we'll see how this thing doing with. So, yes or no? Calculate the matrix product. Alright, now what you have? Alright. Hold on there, let me check on something here. Yeah. So you have right here, so. You want to multiply one matrix by the other. So remember, I'm going to row by column. Alright. So if I have row 1, I'm going to call this R1, after this, alright, times column 1. Column 1 of this column. You see? So, I'm going to put the answer right here, so. In fact, what I'm going to do, see, I rewrite the matrices then. 5, 4, negative 3, negative 2 times 2, 1, negative 4, 0, 3, 6. I'm going to multiply them out here now. So it's going to be row 1 times column 1. You see? Now what are you going to have? You see in the answer, this going to be row 1, column 1. So you must multiply row 1 by column 1. Remember the steps and so on and so forth. You remember them things I know. Now, you're going to put the first element in the answer here, so, plus the second element right here, so. So, first come here, so, second come here, so. You see? So, if you get the first element, you say, first element in a row 1 by first element in a column 1. That's going to be 5 by 2. You remember it? 5 times 2 plus. And then the second element now. Second in a row 1 times second in a column 1. Going to be 4 by 0. Plus 4 times 0. So you see that? I'm going about them business here. Alright. So, that's going to be the first thing. Then, row 1, column 2 now. So you're going to concentrate on column 2. Let me see something I know. This is row 1 times column 2. I'm going to do row 1 by column 2. The first element multiply 5 by 1 plus the second one them 4 by 3. So it's going to be 5 by 1 plus 4 by 3. You see that? So 5 times 1. The first element in a row 1 by first element in a column 2 plus 4 by 3. First in a row 1, the second in a row 1 by second in a column 2 plus 4 times 3. Alright, so now that you remember what I want you pause the video and finish this. and write down the product for me. Alright, so you're finished. Alright, just write down what you have, and then we're going to continue this thing here. So, the next one, a row 1 by column 3. Call that C3, column 3. First by first, 4 by negative 4, plus second by second, 4 by 6. See? First in a row 1 times first in a column 3, plus second in a row 1 times second in a column 3. So that's the pattern, you see. So a 5 by negative 4, you have 5 times negative 4 plus 4 by 6. So you're going plus 4 times 6. Alright. Now, whatever you get here, so in a row 2 and column 1. So you must multiply row 2 by column 1 now. So you're going to be row 2 times column 1. So we have first in a row 2 by first in a column 1 plus second in a row 2 by second in a column 1. Alright, so you have negative 3 by 2 plus negative 2 times 0. Then you're going to have row 2 by column 2. So a column 2 with it now. So that going to be first by first, negative 3 times 1 plus second by second, negative 2 times 3. Then it's going to be row 2 by column 3. So in that case now, what you're going to have is first by first, negative 3 by negative 4. So you have negative 3 times negative 4 plus second by second, negative 2 by 6. So that's a negative 2 times 6. You see? So we simplify this thing now. We say 5 2's 10 plus 4 0 0. Then 5 1 5 plus 4 3's 12. 5 by negative 4 negative 20 plus 4 6 24. Yeah, so negative 3 by 2, that's a negative 6 plus 0, because negative 2 times 0 is 0. Negative 3 by 1, that's a negative 3 plus negative 6, same as minus 6. And then 4 3 is 12. Negative 3 by negative 4, a positive 12 plus negative minus 2 6 12. So when you do that now, what you get for the matrix product, 10 plus 0 are 10, 5 and 12 are 17, negative 20 plus 24 are 4, negative 6 plus 0, that's 6, negative 3 minus 6, that's a negative 9, 12 minus 12 is 0. Alright, that you get? Wonder if we make any mistake. But anyway, if you see any mistake, just tell me in the comment section. Might have to redo the something video or make a second one if you make mistake. But anyway, it says state why the two matrices in A1 are conformable for multiplication. Alright, you see what happened now? You're going to multiply. When you multiply row 1 by column 1, you have the first by first plus second by second. First in the row times first in the column plus second in the row times second in the column. That means the number of elements in the row on the first matrix must equal the number of elements in the column, in each column from the second matrix. So that is why the number of elements you have in the rows for the first column equal the number of elements, the number of elements you have in the row, in each row for the first matrix equal the number of elements in each column for the second matrix. That is why. You see, the thing is, you see, if you did have 2, 1, negative 4, 0, 3, 6 multiply by 5, 4, negative 3, negative 2, what would have happened is this. You would have say, first in a row, if you have row 1 times column 1, the first multiplied for 2 by 5, first element in a row 1 times first element in a column 1, plus. Alright, so you have 2 times 5 plus second element in a row 1 times second element in a column 1. That's a 1 times negative 3 plus the third element in a row 1 times the, third element in a column 1. So this could multiply, right? In this case, you have 3 elements in the row for the first, but only 2 elements in the column for the second. Can't do that, can't multiply. But in this case, it works. First times first plus second by second, and that is it. Alright, so let's see what else I go on as now. Determine the inverse of, alright, the inverse of this matrix. 5, 4, negative 3, negative 2. So you have 5, 4, negative 3, negative 2. And you want the inverse. Alright, so just remember that when it comes to inverse, right? Inverse of a matrix, how it really go is that if you have the matrix A, B, C, D, the inverse will be 1 over the determinant of A, D minus B, C, times the interchange A and D up here, so A down here, so change the sign of B and C, negative B, negative C. Alright, 3, 4, negative C. So this will be 1, if you follow the formula, 1 over A would have be 5 times D would have be negative 2 minus, and then B, C. B would have be 4 times C would have be negative 3. You see? Multiply by, interchange the 5 and 2, negative 2 come up here, so 5 come down here, so change the sign of the 4 to negative 4, change the sign of the negative 3 to positive 3. So what you have, 1 over 5 by negative 2, a negative 10, plus 12, and negative 4 by negative 3, a positive 12. And negative 2, negative 4, 3, 5. You see? Then after that, when I say 1 over, this is going to be 2. Half by negative 2, negative 4, 3, 5. Now you must multiply the half by the matrix. I remember say when you multiply a number by a matrix, each element in the matrix multiplied by the number, right? So what you're going to have is half times negative 2. Negative 2 over half, where I'm negative 1. When you work it out, right? Negative 4 over half, and times half, I mean. Negative 2 by half, and negative 1, negative 4 by half, and negative 2, 3 by half a 3 over 2 and 5 by half a 5 over 2. Alright, so that is what I have there. That's a 10b. Alright, 10c, our matrix. We're going to leave this for our next video.